polar vector and axial vector. Okay, so polar vector in the direction of motion, in the direction of motion. Then what about the axial vector? Axial vector is along the axis of rotation. Okay, so suppose something is rotating in this direction, so your vector may be along here or maybe downward. It all depends on direction of rotation. So if I rotate in this direction, it may move in upward direction. So this is what we call it as the axial vector. Okay, so about this we will discuss more in the coming videos. Or if you change the direction, it may be in the downward. Okay, so we'll go with the few more types of vector. Very important again, the fixed or free vectors. So you can say fixed and free vectors, not all. Fixed and free vectors. Free vectors. Okay. So what exactly the fixed and free vectors? Okay. So first one, if I take the fixed vector, so fixed vector. So what do you mean by the fixed vector? So if you take a vector, so you can say this as the initial point. Okay, if you take this as the initial point, so fixed vector is one whose initial point or starting point is fixed. The vector whose initial point or starting point is what it is fixed. So we can, if you take the example, let me write the definition. The vector whose initial point is fixed. The vector whose initial point is fixed is called fixed vector. Okay, the vector whose initial point is fixed is called as a fixed vector. So what are the examples? Many times we should remember the example. Suppose if you take a position vector, okay, so suppose if I take the coordinates x and y, so if I take the position vector, suppose it is here, so vector will be like this. Okay, now after some time, if suppose it comes here, so again you have to draw the position vector from here only. Okay, so vector may be changing from a point to another point, from A to it may come to B, but what about its initial point? Initial point is fixed, that is what origin. Okay, so whatever may be along with time, it may come to this point. Okay, so again what, you have to start from here only. You have to start from origin or reference point. So reference point is what always fixed. All position vectors are starting from the origin or reference point. Okay, so that is why their initial points are not changing. These initial points are not changing. Initial point. So what is happening? They are not changing. It is fixed. Where it is fixed? It is fixed at origin. So that is why you can take example for fixed vector. Vector is position vector. Position vector. Okay. Position vector is the best example for what? The fixed vector. Okay. So why it's these vectors, all position vectors are starting from origin. Okay, so it will not change. Okay, so no need to write the what if they ask the reason, because its starting point is not changing. It always starts from the origin. Okay, so similarly if I take free vectors, the free vector doesn't mean that the vectors which are free of cost or something. Okay, so what is the free vector? Free vector is one whose initial point is not changed, not fixed, it is changing. Okay, so simply we can say the vector whose initial point is not fixed, simply we can say not fixed, is called free vector. Okay, is called free vector. So what is free vector? The vector whose initial point is not fixed. Okay, for example, you can give many examples like a position vector. So suppose if body is here, if it is from A to B, so what is position vector? This is what position vector. Okay, suppose if body move from B to C, so what is the position vector from B to C? It will come here. Okay, so position vectors may change. If I take the your coordinate system, so a point is here at t equals to 0, so a point is here at t equals to 0, so it may come here at t equals to t1. Okay, so this is what position vector, this is what the position vector. Okay, or sometimes at t equals to t2 it will come here. So now from t1 to t2, what is position vector? This is what position vector. Before its initial point was here, now its initial point is here. Okay, so as displacement changes, as time changing, the initial point may change or may not change. Okay, so most of time it will change, so that is why. So better example is what we can say displacement vector. Okay, so example is what? Example is displacement vector. Displacement vector. Okay. So displacement vector is the vector example because its initial point is changing with the time and position. Okay, but in case of position vector, initial point is fixed. It is always a reference point or origin. Okay, so these are the fixed and free vectors. So one more important type, zero vector or null vector. Zero or null vector. Okay, so zero or null vector. So what do you mean by zero or null vector? As its definition or as its name is only saying, zero or null means what? Nothing. So zero means what? Its magnitude is zero. Actually, in fact, you may ask, then zero means where is the vector? Okay, sometimes it will come in action, or when we take example, you will understand. So in a simple way, if I define this one, the vector whose magnitude is zero. The vector whose magnitude is zero is called zero vector. Is called zero vector or null vector. Okay, so null means what? Nothing. So zero. So zero vector or null vector. Okay. So suppose you are having a vector A. Okay, so suppose you are having a vector A and its magnitude is same. So magnitude, how you can write? You can write it as say 30. Okay. You are having vector B. Say its magnitude is also 30. If you make A minus B, magnitude of A minus B, so what will happen? It will become 0. Okay, so this resultant vector is what? It is going to be what? Zero vector or null vector. So better example if I take, suppose you are in the game of what? War of Turkey. So what will happen? You are having a rope over here. So some 10 people are pulling it from this side. Okay, so some people are pulling it from this side, and another group of people are pulling it from this side. Okay, so another group of people are pulling from this side. Okay, so this side also 3 people, this side also 3 people, and all are having the same energy. So these people are pulling in this direction, so these people are pulling it in this direction. Okay, so if the amount of energy is same from both sides, what will happen? This will not move either on this side or this side. Okay, so what will happen? So net net force on this one will become what? It will become 0. That means it is not moving, but vector is there. Resultant vector should be there. Okay, but it is not doing means what its magnitude is what going to be a 0. Okay, so this is what you can take it as a best example. Or suppose you can take a body here. So some 5 Newton is acting from this side and another 5 Newton is acting from this side. Okay, so from both sides force is acting. When both side force is acting, this will not move anywhere. Okay, but 2 vectors are acting on that one means what? Resultant vector should be there. So some vector to there, but its resultant is what? Its resultant is 0. Okay, so those kind of vectors we call it as the 0 vector or null vector. Okay, so this is what the 0 or null vector. So whenever if they ask what is the magnitude of null vector, so if they ask the magnitude of null vector is going to be what? It is going to be 0. Okay, direction, of course it has direction. Okay, so what about the one more very important type, that is what? Negative of a vector. So what do you mean by negative of the vector? Suppose you are having the vector A here. Okay, so you can call this as the vector A. So what is its length? Its magnitude is say some 2 meter. Its magnitude is say 2 meter. Okay, so direction is in this direction. This is what the direction towards west. Okay, so if I draw one more vector here, so vector B. Okay, so this vector is have the same magnitude. Vector B magnitude also 2 meter. Vector A also 2 meter. Just I am taking A as a reference, and I have measured the length, so same length I am taking. But now what I will do, I will change the direction. So I will take the direction here, opposite direction. Okay, so now you can call the vector B is negative of vector A. Then you can define yourself. What do you mean by negative of a vector? The vector whose magnitude is same, but opposite direction. Both are in opposite direction. So you cannot call this as the negative of a vector. The direction should be opposite. Okay, direction should be opposite. Suppose one is here and another is here. You can't say negative of a vector. Okay, so same magnitude but exactly opposite direction. So those kind of vectors we call it as what? Negative of a vector. Okay, so how we can define it? So the vector whose magnitude is same but direction is opposite. Okay, so that kind of vector is called as what? That kind of vector is called as negative of a vector. Okay, so here vector B is negative vector of A. In this example, vector B is negative vector of A. Okay, suppose if you want to write in mathematical form, so what I can write it as vector B is equals to minus of vector A, or magnitude of vector B is equals to minus of magnitude of vector A. Okay, so better no need to mention like this. So we can simply say vector B is equals to minus of vector A. This negative indicates that what? This negative indicates the direction of vector A is opposite. Okay, direction of vector A is opposite, or direction of vector B is opposite to A, or A is opposite to B, whichever you can say, it is correct only. Okay, so this is what the negative of a vector. Okay, the vector whose magnitude is same but direction is opposite. Okay, So as you know, B you can write it as what? B you can write it as minus of A. So can I write? You can write like this also. If this is the vector A, so this is what vector B. But since they are having same magnitude and opposite direction means you can write this as minus of vector B. Okay. So in place of B you can write it minus of vector A also. Okay. So it will help in many cases in cancelling the vectors when they have the same magnitude opposite direction. So that we'll see when we come over there. So this is what the negative of the vector. A vector whose magnitude is same but direction is opposite. Okay. Okay. Next we'll see a more important type, that is what we can call it as equal vectors. Okay. So we can call it as equal vectors. So when we can say two vectors are equal, what about a negative vector? The vector whose magnitude is same but direction is what? Direction is opposite. Okay. So then what about equal vectors? Two vectors are said to be two vectors. Two vectors are said to be equal vectors. Two vectors are said to be equal vectors if they have same magnitude and same direction. In case of negative vector, same magnitude but opposite direction. So here it is what? Same magnitude and same direction. Suppose you are having the vector A here. Okay. So its magnitude is say 20. Okay. So what about the another vector? Another vector is also here, and this is what vector B, but its magnitude is also 20. Okay. So what will happen here? Magnitude is same. So magnitude is same. So what about direction? So direction is also same. If you take these two, so direction is also same. Direction is also same. Okay. So if both magnitude and directions are same, then you can say those kind of vectors are what? Equal vectors. Okay. So any two vectors or any vectors whose magnitude is equal and direction is also same, then we can call it as they are the equal vectors. Okay. So this is what about the equal vectors. So one more important vector, parallel vectors. Parallel vectors. So what do we mean by the parallel vectors? The vectors act along the same lines or along the parallel lines. The vectors act along the parallel lines are called. The vectors act along the parallel lines are called what you can say parallel vectors. Parallel vectors. Okay. So if this is the vector A, then if you take another vector B over here, so A and B are said to be what? Vector A and B are said to be parallel vectors. Parallel vectors. Okay. So then you may ask, then what is the difference between equal vectors and parallel vectors? Okay. In equal vector, magnitude and direction should be same. But here they did not mentioning anything about the magnitude. What they are saying just should be the act along the parallel lines. Okay. So now here, if this is the vector A, and if you take another vector B over here, they are acting along the parallel, but magnitude is not same. But these are also what? These are also parallel vectors. These are also parallel vectors. Parallel vectors. Okay. So I hope you got difference between equal and parallel. These two are what? These two are not equal vectors, but these two are parallel vectors. Getting? What about this one? These two are parallel vectors also, and these two are what? These two are equal vectors also. Okay. But here opposite is not true. If all parallel vectors are not equal vectors. Okay, equal vectors may be a parallel vectors. Okay, so here magnitude matters. Okay, if you change the direction, you can call them as the anti-parallel vectors. So instead of this one, I will take vector A here and vector B in this direction. Okay, so acting along parallel but in opposite direction. Okay, so vectors acting along vectors acting along parallel lines but opposite direction but in opposite direction. So if vectors are acting along the parallel lines but direction opposite, so then you can call it as what? Then you can call it as anti-parallel vectors. Okay, so these are called as what? Anti-parallel vectors. Okay, so the vectors which are acting along the parallel but direction is opposite, so they are called as what? Anti-parallel. Okay, so you may take A over here and you may take B over here. So A and B are what? A and B are what? Anti-parallel vectors. Okay, so these are what? Anti-parallel vectors. Okay, so I hope you are getting what exactly parallel vectors and equal vectors. Okay, so this is what the parallel and equal vectors. Okay, next type, that is what? Collinear vector. Okay, so collinear vector. So what do you mean by collinear vectors? Okay, collinear vectors means suppose if simple the vectors which are acting along the same line, the vectors which are acting along same line, are called what? Are called collinear vectors. Okay, collinear vectors. So you can understand, suppose this is the line, so vector A is acting here and another vector B is acting here. Okay, so they are acting on what? They are acting on the same line. Okay, so A and B are acting on same line. A and B are acting on same line. So vector A and vector B are what? They are collinear. Vectors. Okay. Then you may ask, vector A is acting in this direction, but on the same line. Vector B is acting in this direction. Don't think of magnitude, direction. Don't think of magnitude. So even direction is not required. What is our definition saying? They should be on the same line. Whether they are in opposite direction or different magnitude doesn't matter. If they are on the same line, you can call it as what? You can call it as collinear vectors. So here also A and B are what? A and B are collinear vectors only. But if you want to give both, you can call it as collinear vectors only. If you want to give the different name, so you can call it as like vectors, and these you can call it as unlike vectors. Okay, so that is not required. So if they are acting on the same line, so what you can say, they are the collinear vectors. Okay, so similarly one more thing, that is what? Coplanar vectors. Okay, so coplanar vectors. So what do you mean by coplanar vectors? Okay, so vectors which are acting on the same plane, vectors acting on same plane. So vectors acting on same plane are called coplanar vectors. Okay, are called coplanar vectors. So suppose if you take this board as a plane, so I will draw some vectors over here. Okay, so whatever may be the direction of something, they all are on the same plane. Nothing is coming out of the board. This is another plane, so nothing is coming here. Okay. So this is what these are what we call it as the coplanar vectors. Okay. So instead of that one, if you take plane like this, if you take this as the plane, so now vectors are what? Eigenvectors are going to be here. Okay. So vectors are going to be here. They all are what? They all are on the same plane. They all are on the same plane. Okay. So these two are what? These were example of the what? Coplanar vectors. Okay. So coplanar vectors. Okay. Instead of that one, if you are having a plane over here and some vectors are standing on this one, if another vector is coming out of the plane, so this is going to be in another plane. Or if something is coming over here, this is going to be what it is in another plane. So this is not a coplanar. Okay, this is not a coplanar. Okay, I hope you are getting what exactly I am saying. If you are taking a plane, so any vectors on that plane are what? Coplanar vectors. Instead of that one, if something is coming in another plane, then what you can call it as, that is not going to be about coplanar. So remember, coplanar vectors are the vectors which are acting on the same plane. Very important, remember unit vector. So very important, that is why I am taking at the end. Unit vector. So what do you mean by unit vector? A vector whose magnitude is 1 unit. Whose magnitude is 1 unit. Okay, so is called unit vector. Remember, very important. So what do you mean by unit vector? So suppose this is the vector. So if you take the vector A, so if its magnitude is equals to 1 unit, so that is what is called as the unit vector. Okay, so how we can represent the unit vector? So unit vector is represented by cap. Okay, so this is what the symbol. So you can simply call it as the cap. So a cap. So unit vector of A is what? You can write it as a cap. Or unit vector of B, we can call it as what? B cap. Okay. Unit vector of velocity, what you can write? V cap. So what is A cap, B cap, V cap or something? So unit vector A cap means vector A divided by magnitude of vector A. Okay. So vector A divided by magnitude of vector A. So suppose you are having one vector over here. Okay. So vector A is here. So its magnitude is say some 10 meter. Okay. So now if you calculate what is the unit vector of A is vector A, what it is? Vector A divided by magnitude of A. So divided by magnitude of A. So vector A is what? It is 10 meter in some say west direction. So 10 meter in west direction. So 10 meter in west direction. So divided by. So magnitude of A is only 10. Direction not required. Okay. So 10 will get cancelled. So what you have to know? 1 meter in west direction. 1 meter in west direction. This is going to be what? Unit vector. I hope you are getting. Suppose velocity vector V is what? Suppose velocity vector V is say 60 km per hour towards Bangalore. 60 km towards Bangalore. So unit vector of V cap is equals to what? 60 km per hour towards Bangalore. 60 km per hour towards Bangalore divided by what? Divided by magnitude of this one is what? Magnitude of this one is 60. Okay. So divided by 60. So 60 will get cancelled. So V cap is what? 1 km per hour towards Bangalore. Okay. I hope you are getting what exactly unit vector is. If you multiply this with the magnitude, what you will get? You will get again unit vector only. So suppose if I write it here, so if I take magnitude on this side, so what will happen? Vector A is equals to A cap into magnitude of vector A, because you have divided by magnitude of vector A. So you can find the vector A by multiplying unit vector with vector A. Okay. So suppose if somebody asks you where is Belgaum, so you will say some 100 kilometer in this direction. Okay. You cannot go and show that okay it is here. So simply you will show this one. Okay. What this hand, you can take this as a unit vector. Okay. If you multiply this some thousand times, so what you will get? You will get it as the distance of Belgaum, like that. So unit vector means the smallest unit measurement. Suppose if it is 100 kilometers, so 1 kilometer is what unit vector. Suppose it is some 100 centimeter, so 1 centimeter is what going to be your unit vector. Okay, so if you multiply 1 with 100 times, so you will get it as what? You will get it as the real vector. If you multiply 1 kilometer 100 times, so what you will get? Or you add 1 kilometer 100 times, so what you will get? You will get it as the actual vector. Okay, so that is what the unit vector. So remember, it may be a cap or it may be a n cap, whatever. A cap means what? Vector A divided by magnitude of vector A. N cap means what? Vector n divided by magnitude of vector n, whatever. So like that you have to represent. But usually in our coordinate system, so if you take 3 axes over here, x, y, z. So along the x unit vector, this is what going to be unit vector. So this is what I will take as I cap. So this is what going to be a unit vector. This I will take it as j cap. So along that we will have to take it as a k cap. So I cap, j cap and k cap are unit vectors along x, y, z. Along x, y, z. I cap, j cap, k cap are unit vectors along x, y, z. Then you may ask, so why I cap, j cap, k cap only? So you can take L, M, N, whatever. You can take some x, y, z. That depends on you. So standard what we are using is I cap, j cap, k cap. I cap is always along x, j cap is always along y, and k cap is along always what? Z. Okay. So now what will be the magnitude of I cap, magnitude of j cap and magnitude of k cap? What is the magnitude of I cap, magnitude of j cap, magnitude of k cap? So that you will think and tell me the answer. Okay. So think of answer. We will discuss in the next class. Okay. So simple. I cap is unit vector means its magnitude. Obviously, you can easily get the answer.